So before we start, I just wanted to introduce myself. I'm Mahesh. I'm into ETL as well as reporting from last 10 years. Recently, we started doing some POCs on big data, and then the primary focus is on ETL and as well as the databases. So I am currently working on OBI and Oracle along with this NoSQL database of Oracle. So this is about me. Uh, so today's training will be focusing on the difference between the SQL databases and NoSQL database, and how do we use NoSQL in terms of mm, what do you say, DDL, DML, and BCL. What are all the database what do you say languages? The typical database operations are there. Okay, so the more emphasis is on the differences between the SQL as well as the NoSQL. Okay, so the agenda for today is a brief history about the databases and how the NoSQL databases evolved. What is a NoSQL? What is the CAP theorem? Hmm, what is the pros and cons because of this? And what are the different types of NoSQL databases we have? How does a data model look in an RDBMS system and a NoSQL system? What are all frameworks that are available? A simple demo and then a few questions. And it's a wrap-up session. Like we have the question. So typically, right, in the olden days, before the database evolved, everything was documented on paper, and slowly the Excel sheets came. And then from Excel sheets, the RDBM, the database systems evolved, and from there RDBMS systems came. Now, typically these RDBMS systems are linked to the web applications, and there's huge chunk of data that is coming into the database. Now, analyzing this, putting records in a straight way, and pulling reports on top of them was becoming a huge task. The analysis, the reporting was a huge task. So from there evolved the data warehouse systems. So OLTP OLAP came into picture. And from there, right, typically these are all relation models based on column relationships or rows were inserted. Now, if you see any database system, they are typically stored in a rows. But what if there is a relationship between a document and a column value, or there's a huge set of data where it is used in multiple places, and you have to find out there is no direct relationship between them, but there is a word-based or key-based relationship. So that sort of issues were not resolved using the RDBMS system. That's where the scalability concept has come into picture, where distributed systems, link between these distributed systems had to be defined. So that's where the different approaches came into picture, like the master slave or the sharding. Sharding is like horizontal partitioning. Now, in-memory concept came into picture. So these were all solving the amount of data that is being stored and how it is getting retrieved. But there was no solution for the horizontal scaling, where whatever is the type of data, any data set, whether it's a word-based data or it's a column-based data or a document-based, file-based, anything. So there's no link between all these heterogeneous form of data. So that's where the concept of NoSQL came into picture. Okay, so NoSQL typically any database follows the ACID properties: atomicity, C, and ID. Okay, now because of that, we have concepts of joins, and then the primary key foreign key relationships kind of thing, right? So that issue was that is a typical RDBMS system. Now, what a NoSQL or a NoSQL database system follows is the CAP theorem. Okay. So what it allows us, it helps us in having consistency, availability, and data in partitions. Now, what's the purpose of this is, say suppose any database as it follows the ACID properties, you need to have multiple joins to get the data from, to get a set of information from multiple databases or multiple tables. So what is that involved? What is that doing is, it is making data available only at few pieces at one point. But what if there is a multiple databases or multiple set of data, like one is a database, the other is a file management system. So how does these two interact? The what do you say, database RDBMS system doesn't support that. So in order to solve that, our NoSQL came into picture. What NoSQL is doing is this. It is using the nodes concept or map reduce concept, where you will have link between the data which is with whatever format is it. So that way you can relate a file to a database table and get the data if it is required. So a typical example is, if you go to Google and if I search for something like NoSQL, if you see, we have the PDF books, Word files, or if you just click on search, you'll see multiple. It can be a PPT file, or it can be a URL link, or it can be an PDF file, whatever it is. So these are all present in multiple databases or multiple locations or different locations, which are not having similar characteristics. So how is Google getting all this data? So there's no, it's not an RDBMS system, right? You have something on the web application like Facebook, um, okay, or something in the any of the what do you say, cloud system, where it is present on cloud. So how does it relating to all this, right? So that's the beauty of a NoSQL system. So what is it making sure is caps? So consistency, and then availability, and then partitioning, right? So these we will have a detailed discussion in the coming sessions. Okay. So typically we have four types of SQLs, NoSQLs. One is key value based, where you have a key and the respective values. Similar to a column in an RDBMS system, you have one column and you have multiple values on it, right? So say suppose employee is there, employee ID is the column, you have employee details as a table, where you have employee ID name, first name, last name, email ID, mobile number, etc. in that table. And you have employee salary details in another table, employee project details in another table. Okay. Now all these three tables have employee ID. Now in a typical RDBMS system, you join these three tables to get the salary, project, and the personal details. So so the key here is employee ID, and the values are his respective project and salary details. So in an RDBMS system, you have it in a multiple tables. But here you will have employee ID, and all its values are stored in a common place. Either it's an XML file or something like that. Okay, 1 second. Okay, so that's the key value systems, and then there's a column family, where One column you have it as a primary in this thing. It's similar. At some point, it is similar to key value. So you have a column. All similar columns will be grouped like employee ID, his department ID. So employee ID and department ID have a direct relationship, right? So you have few such things in as a group, so just like you maintain the table columns, right? Just like for employee details, you have employee ID, salary ID, and then his department ID, and what are all his attributes are there. You will have it as a single table. Okay, so that's the column family typically. And then the graph is similar like this. I'll show you an example. So there's this guy Joe, okay, and he has some what do you say? He's having someone his address, okay, and then he has some orders, okay, and he is followed by someone else. So some person is following him, okay, following him on Facebook, and he bought something on Flipkart, and he has his address stored in some what do you say? His address, he has some social security number or something like that. So these three are different entities. I mean, these three are three different things, but they don't have a what do you say? Uh, in reality relationship. My intention is these three are attributes of this person, say some person. But if you see, his orders has nothing to do with his followers, or his orders has nothing to do with he has some relationship with his address, but there's nothing directly related. Okay, so in the graph database, what you do is you just have a relationship to all the entities or all his activities done. Okay, so these if you see in the what is it by example wise, all the database looks the same, but how are they created and how do they interact makes a difference. Okay, now if you see all this, right, but the pros will be they are very fast. They can be scalable because there's no relation like the primary key, foreign key relation constraints are not there. You can just pump or dump the data, how whatever is the format. They are just linked by their what do you say the keys. Okay, so you don't have the problem of atomicity or acid properties. And obviously, for obvious reasons, they are able to distribute horizontally. Okay. Now the cons are the data modeling is not happening here, right? So there's a lot of redundant data that is coming into picture, and going by the standards of industry, right? There's a lot of what do you say redundant data that is coming. For example, if you take Facebook, right? You will have the same photograph or a video shared by multiple people. Okay. Now, if I am storing it based on the, so I have shared a photograph and someone has been tagged into it. Okay, and there are almost 1 lakh likes to that. So if you are going by a key value storage database, all the 1 lakh people ID will be tagged to this photograph, and for these 1 lakh IDs, the photograph will be stored. So say suppose it's a 10 MB one, 10 MB into 1 lakh, it is taking almost 10 to 20 GB of space. So one photograph which is 10 MB, you are unnecessarily storing it. You are allocating a space of 10 to 20 GB. So that's the problem. That's the cons. That's the problem with this. So for obvious, when it is a schema-less thing, uh, there's a consistency and it's very distributed. I mean, you can distribute to multiple places if one database or one particular value is dropped or something like it is deleted accidentally, you can retrieve it from other location because it's stored from in multiple places, right? So that's the advantage of having it as distributed. Uh, we say the performance and scalability is available, but at what cost? It's at the cost of space. Okay. So as it doesn't have any schema, you don't have the what to say the asset or transactions are not allowed here, or the joins. We don't have the concept of joins here. Okay, it's similar to the concept of views. Okay, so typically any NoSQL database or a NoSQL system is an open source as of now. Okay, so it's very cheap and easy to implement. And as there are multiple nodes, you don't have the problem of single point failure. I mean, if any one single point is failed, you can have other places where you can restore it back. Okay, and you can easily replace them and replace them with a new one. And for obvious reasons, it's very easy to distribute. It doesn't require any schema. You don't have any architecture design for it. I mean, on a high level, you have an architecture design, but you need not, what to say, every time you can say. Say, suppose the typical problem with RDBMS is, so tomorrow if you want to add a new table or a column, and it is having dependent columns to the tables or columns that are created earlier. Now you have to make sure there's no what you say. You have to make sure the constraints or the data level discrepancies doesn't problem. So the architecture wise, we have to take utmost care in Arduino system. But here you need not worry about that. And for obvious reasons, you can scale up and scale down. Okay. The data consistency will be there for obvious reasons. So this is all. Now, what am I losing because of this NoSQL databases? The concept of joins, okay, and then grouping by say employee ID. As there is no, what do you say, uh, primary key foreign key relationship kind of thing, or you are not having a simple what do you say, an employee ID being repeated, or you don't have a typical RDBMS system. There's no group by, there's no order by, because the data is scattered or it's not in a set increasing or decreasing format. So asset transactions. So I delete it here. It should be, if I delete in a primary table, first it will not allow me to delete in the foreign table, right? Foreign key table. So what am I doing? I'm having there a consistency in the RDBMS system, but here you don't have that. So if I delete it one place, there's no problem of re-verifying in other areas. It is repeated data anyway, right? So asset transactions we are losing. Uh, Here SQL is we cannot the typical SQL queries we cannot write, right? But still it's a powerful system because RDBMS system is allowing us to have the relationship model, right? So you can join data from multiple tables and get it, but here there's no relationships kind of thing. So SQL, which we all know, we are losing it. So altogether we have to learn a new thing. That's NoSQL queries. Okay? We say that the integration to other applications that support SQL, we are losing that, right? So say suppose Java and Oracle will interact using the SQL queries, right? Now, when I have to what to say, when I use the NoSQL, altogether I have to write a write queries in a new language. So the primary interaction or integrations are not possible. So altogether, we have to create a new system or ecosystem, and you have to start from that. Okay. So simple example is Oracle has an what do you say, has tied up with Informatica. So Oracle database and ETL tool Informatica have a tie-up, and so if there are any changes to Oracle database, the Informatica will be what to say, intimated about the changes, and they change the code accordingly. But now altogether NoSQL is a different database, right? If any changes occur at the NoSQL thing, there will be no you never know what is the front end or the integration applications that you are using, right? So the, it's like you're starting from fresh again. So you have to interact with many systems, you have to create a communication system between them altogether. So at this point, it's an initial stages, right? So that communication part will be difficult. So few examples for the this what do you say NoSQL database are from the graph-based database. Neo4j and Titan are one example. And key value is Cassandra. This is used by Facebook. Oracle has Berkeley DB, and Amazon's DynamoDB is there. And column based is Google's BigTable. That's these are the pioneers actually. Google BigTable and Amazon, and then followed by Cassandra from Facebook. And then now came the HBase from Apache. And document-based database management systems are typically MongoDB and CouchDB are there. Okay, so these are the examples of databases. So, hmm, so this is about what we will, on a high level, what an NoSQL is. So in the coming sessions, right? So we will, I'll what you say, let you know how to write a NoSQL query uh, in a key value system or in a column family. So I'll take an example of Cassandra main. My primary focus will be on key value database because for us it's very easy to relate to our RDBMS systems. So in the coming classes, we will take a next step forward, and then we will write NoSQL queries on either on HBase or BigTable. Okay, as Cassandra is available. What do you say? It's a open source system and it's freely available. We will primarily focus for this 5 sessions mostly on Cassandra, how to write the SQLs, NoSQLs in similar lines to SQLs, like on how to create tables or uh, how to create, modify or delete, and then how to retrieve a typical where conditions. How do you write that? Okay. So that's the primary emphasis of this session. Now, when we say about NoSQL, right? At this point, major companies like LinkedIn, Twitter, or Facebook or Google are using NoSQL databases. But going forward, right, all the companies will start using NoSQL. At this point, it's limited. That's a limited space. But going forward, it will increase as I said earlier, right? If I have multiple data systems and if I have to communicate with them, at this point, RDBMS is the only solution. But what if I have to search my data in multiple systems? Like there's a third-party system where I get the data in Excel format or Word format, and I have to search for a value. So suppose one simple example is there's an automotive industry, say suppose Honda or something like that. So they get parts from multiple locations, okay, and this particular part is coming from a third party vendor, okay, and that is being fixed at a different location, and that is sold by multiple dealers, and while doing service, this particular part is creating some problem. Okay. Now, from a management perspective, I want to see the performance of that particular part or accessory. Now, I want a complete information stating that how many parts came in, how many were sold, how many were being sold during servicing, and how many were being sold during what to say, the time of assembling the car. Now this particular data is present in multiple places, and there's no point. There's the integration of these multiple places or multiple source systems is a typical is quite different from RDBMS system, right? So that's where the point of the usage of NoSQL will come into picture. So going forward, it's a huge industry. From IT perspective, it will take It's like it's boom kind of thing for us. So, so on a high level, so what will be covered in the session, in this 5-day session is how to use NoSQL, mainly in Cassandra database. Okay. Uh, so I'm done. So if you have any questions, please let me know. Yes, Ravan. Yeah, I have unmuted you. You can speak. Hello.
Hello.
Yeah, Ravan, tell.
Hello. Yeah, what's the difference between that big data and NoSQL? These are the same, or the concept is different? Like,
No, no, no.
hello.
Big data is a complete ecosystem actually. It has the front end, ETL, database system, everything. A part of it is a NoSQL database.
Okay. Because I don't have any idea about big data and NoSQL because I'm completely into a different platform. I'm into automation testing and
Okay. Okay.
right now currently in manual only, but I want to switch to another platform because
Okay.
not interested to continue in manual testing.
Okay. Okay.
So I'm just desperately looking into another platform. So what's the best thing I can go for, like to search jobs in NoSQL? Only NoSQL only I need to consider. Is there another thing I need to learn?
Uh,
Like,
Yeah, so at this point, right, I mean, learning NoSQL will be a good start because uh, any system, if you take even now at present RDBMS systems, having a knowledge on database as a database admin or a database developer or a database tester, you have multiple opportunities. So similarly, in a big data ecosystem, having a knowledge on NoSQL is similar to a database admin or a database developer or a database tester, right? So if you
mm,
want to continue as a tester, then your concentration will be a NoSQL database testing. Okay, so that requires knowledge on, just like you require knowledge on SQL for doing database testing, right? So here also you should not have a knowledge on NoSQL to learn to do the testing on NoSQL databases.
for this, what are the tools are required to install the for NoSQL practicing? Like,
Cassandra is an open source system, okay? So just like
okay,
Oracle database is also free, right? You can download and install, and having a knowledge on SQL, you can create tables, etc., retrieve the data, insert the data using SQL, right? So
yeah, yeah.
similarly, Cassandra is a NoSQL database. You install that, you create your table structure, insert the data into it, and retrieve it using NoSQL queries.
Okay. In that PPT, you mentioned couple of the database, right?
Yes, right.
So Cassandra is a leading, like right now people are, most of the companies using the most Cassandra only, or what do you say? Like,
MongoDB Cassandra is actually as of now leaving. HBase is also starting. It depends on
okay.
what is the need of the customer actually. See, if you want,
Mm-hmm.
as I said earlier, right, if you want to have a column-based system, which is
Mm-hmm.
similar to what you say, RDBMS system, okay,
Mm-hmm.
then you will go for Apache HBase actually. Or
Okay.
say suppose I want the complete employee ID information, okay,
Mm-hmm.
then I'll have key value system. So employee ID is linked with salary, his department will be linked, his location will be linked, his what
Mm-hmm.
is it, everything. So if you want to
Mm-hmm.
have that way, then you will go for any of these. But Cassandra is leading in this sector, and HBase is leading here. And then on document based, MongoDB is leading.
Okay. So in the course, what are the topics you're going to cover mostly? In only Cassandra you're going to cover?
On Cassandra database, how do we write the NoSQL queries? I'll just show you.
Okay.
It's just like an initial stages for everyone. So it's like what do you say? The end-to-end system. I'm on. What is I cannot show you in just 5 days, but I will relate the SQL queries. How do you write on your typical RDBMS system, and how do you write your NoSQLs on a NoSQL database? So for now, I'm showing it on Cassandra.
Okay. So this course, like this course, how many days is it's complete?
Five,
Like
5 days, 5 days course.
only 5 days?
Yes, 5 days.
Only 5 days. The entire course will be.
The expectation is people know something about SQL query. So that's the main prerequisite that we are expecting, because we just want to showcase how an SQL query is written. Just say suppose I'm creating a table in RDBMS system. How do I write my SQL query? And if I'm creating a same table on a Cassandra database, how do I write my query using NoSQL?
Means the entire NoSQL course is only for 5 days. This is
5 to 7 days it will take. Yeah, because you
okay.
already know something about SQL, right? So you can easily relate how do you write queries and how do you retrieve. We have multiple data query language system, this thing, right? Where condition, select queries, group by, all these things. So how do you have a similar kind of setup in NoSQL? So we wanted to showcase this thing.
Okay. Oh, okay. Okay.
These are
Is
short
this
and sweet courses. Yeah.
okay? Is this helpful for to search for a job with only SQL? Or do I require another additional like to start with my career like in to search new job like the new
See,
SQL is.
I understand. I understand your question. So your concern actually, I got it. So these are all bits and pieces. So if you take simple example, if you take a database has a data model, and your expertise on data model. If you want to know something on the data model, from training perspective, we will take 5 days to make you learn
Mm-hmm,
about how to create a database structure, what are the primary key, foreign key constraints, how a table is
mm-hmm.
created. So making you learn about database model will take 5 days. Making you learn about, sorry, excuse me, making you learn, 1 second. To learn about writing SQLs on top of these tables will take 5 days. And the next
Mm-hmm.
one for that is creating the OLAP system on that. So that will take 5 to 10 days again. So now if you take the complete suite, it will take 20 days or 25 days to learn complete end to end about the database, right? Now,
Okay.
similarly, we have broken this entire course like this. So we are assuming that people know something about the database model in a NoSQL database. Okay. Now
Mm-hmm.
our focus is on how to write the SQL queries uh, in similar lines to the database system. So this course will help you to how to write this NoSQL queries on a database model.
Mm-hmm.
We are safely assuming that people know something about SQL data model actually.
After that, another course will be there. Like
Yeah, we will
what?
start another course coming in after this session. After this 5 days course, we'll take one more 2 3 weeks of gap, and then we'll start again on the next level, the ETL process or the database modeling, how the database a typical model will look in NoSQL databases.
Uh-huh.
So it's a continuous process. I mean, it's a step-by-step process. I mean, we don't want to rush everything or.
Mm-hmm. Like you have entire curriculum, like a course curriculum. I just want to see what are the things
Uh,
you're going to give. Like,
okay. Shall I share you on email after this session? Because
yeah, yeah. Can
I
you
have.
share me that entire curriculum? Like, what are the things you are going to
Sure, sure.
teach? Like in this, I thought only you were saying for. I was just worried about only 5 days. That's I thought it's a complete 45. What's the timing? Like, what's the timings? The same timings you are going to
Same
conduct?
time. Same time. Yes.
6:30 our time, like
Yes, right. Same time, 6:30. See, it's like this. I mean, so we don't want to rush everything because it's a new thing, new concept, right? If you give a plate full of meals for you, at this point you may not have a complete interest on eating everything. So we just want to break it into bits and pieces and make you understand about the entire system instead of just
hmm
pumping in everything.
hmm Uh, do you have any like job market, or you have any idea about in US, in India,
Yes, it's very, very
India?
huge actually. NoSQL, there's a lot of requirement or recruitment that's going on. I thought of showing you some, what do you say, results, how the job
Mm.
market is, but at this point the server is down. I don't know why. So else I would have showed you because simple. I'll let you know simple thing. See, today we have a lot of data that is flowing into the system, and even the client or the end user or the companies who are having the RWM system, they are not able to relate a large set of chunk of data that they are having. A simple example, as I said earlier, right? We have an accessory in an automobile industry, and that's being manufactured by a third-party vendor. Okay,
Mm-hmm.
and its information is coming in a flat file or an what do you say, or through a common FTP location where you go and access it. It can be an XML format or it can be a Word document or a PDF file also. Okay, so
Mm-hmm. Yes.
that is one type of data model. So that's one form of data. Okay, now I have my what do you say. CRM system where my entire parts information is stored in, say, suppose Oracle application, EBS suite, okay, or a SQL server. So these are two different databases, right? Now I have my what to say, the service information in form of a paper, and I'm scanning it and storing it as in a PDF file, and that is what
Mm-hmm.
you say. I cannot read that, right? So I need an third party application where I can read it and copy it into my database. Now you see this all set of data is in multiple formats. It's in different forms, right? Now when I have to move
Mm-hmm.
it into a common or uniform form where I can read it easily, I'm as of now using ETL process to copy this multiple sources data into one common format. Now say suppose there's an issue with the data that is copied into the ETL system or the data warehouse system. Uh, I don't know what is the source for it. So the reverse engineering, as of now, it's not available. Okay, so that's where the big data comes into picture, where you store these source systems also in the data warehouse, and you just link them. So this
Mm-hmm.
part information, service information is coming from this document. So you have a relationship there. Now what is it happening? Typically, the data warehouse is a database. It cannot store the files, right? Altogether, it's a different system. So you'll have a file system again there. Now that particular echo or the ecosystem that is created, it's heterogeneous again, same as the source systems again, right? So how do you interact during that situation is what big data is all about. How do you develop that particular technology? That's what big data is all about. Now here, how do you store the data? In what format? So now I want to store all the documents and have retrieval easy, right? So then I'll go for document database. Now, if I want all the data, what do you say, in a non-relational model, then I'll go for either value based or a column database, either of this.
Mm-hmm.
Okay, so that's how the entire system is. Now our focus here is learning about how to retrieve data from these database systems, these NoSQL database systems. So
Mm-hmm.
every technology or it's the complete ecosystem is having map reduce, hives, pig. So ETL is there. You have front end application, front end UI is developed. Okay, and then we have ETL system. We have database management, database administration, or the entire big data administration. So again, altogether, the entire application is having multiple technologies, and everyone has their piece of cake in it. So now our focus is this part because this is for us, it's easy to relate to the database we already are working, right? I hope you are already interacting with the database in your manual testing.
Yeah, some sort of queries, if
Yeah,
any updates, not complex,
yeah,
simple queries.
yeah.
In the testing, we will check
Yes,
whether
right.
the data is updated or
Yes, right, right.
yeah.
So
Mm,
this you will easily relate actually. So for a starter, for a new person, if you know something, if you are able to relate to what you are actually already doing, that will make you feel good, right? So that's the intention of this course. Start with something which you know, and then make you learn about the newer things later.
mhm.
The market is good. I mean, absolutely good actually.
Come again, sorry.
The market is good for
A
IT
market.
professionals. Yeah.
Okay,
So it's absolutely
okay. Currently, I'm in US. That's why I'm worried about it. In
good.
US,
You must be having a
uh,
good picture than the persons who are in India actually.
actually, that's why I'm new. Even I hear nowadays I'm hearing the big data and these things that data in future this is there like projects will be more like I hear. That's why I want to learn.
Yeah, sure. Our intention is many of the professionals know how to interact with database. So let's start the entire piece of big data with something which you know so that you can easily relate and feel good so that the newer technology which we will introduce sooner or later, you will at least feel that you know something about a piece of big data at least.
Hmm.
Okay, that's the intention of this course.
Yeah, share me the curriculum so that that course
Sure,
curriculum I
sure.
just
So
want to
after
see.
this session, I'll send out an email. Okay. So your email ID
Yeah,
is
raghavendra11@gmail.com.
sure.
Mm-hmm.
I'll send to that. Okay.
Okay.
Okay. Thank you. Any other questions, please?
For me, I'm good. I'm good.
Okay. Thank you. So we will see you back on 23rd or 24th. We'll send out a mail again because count on. Okay. We'll take it and we'll just let you know after the session. Okay.
Sure, sure, sure.
Thank you. Thanks for joining the call.
Thank you.
Yeah.
Yeah, yeah.